students, in this video we are going to discuss mainly about two ARM pseudo instructions. Okay, we have already seen this particular instruction itself, LDR, which actually is nothing but means load the register with the memory value, right? Nothing but you're moving the data from the memory location to this. Then how is it categorized as one of the pseudo instruction here? First of all, we need to see what is a pseudo instruction here. Pseudo instruction is not a part of the ARM instruction set. In fact, it belongs to the assembler. So when the assembler assembles LDR as when used as a pseudo instruction, it must translate this particular LDR or this particular ADR into this equivalent here. You can see here these are the pseudo instructions mentioned, and when the assembler converts it, this will be the actual instruction. That's what I meant. Okay, so there are two of them, LDR, which we've already seen. Okay, and the syntax of LDR is, you can see here, LDR RD comma is equal to a constant. So what happens is we can use a normal move instruction like this. Okay, so there is a range for moving a particular byte or bits. There is a range of moving that much data to a particular register, which is possible in a move instruction. Beyond that, so that range is defined by the designer itself. When it's beyond the range, we actually replace that instruction with a pseudo instruction. This pseudo instruction is actually processed by the assembler itself, and during assembly it is actually converted. Okay, so here you can see here there is another called as ADR, okay, which actually loads the address. Okay, now that address is it's nothing but called as a relative address. So relative to what? So either it can be program relative address, or it can be a register relative address. You can see that we have already given here a relative address, and here it's purely constant. So to give you an example here, so we have already an example here. Okay, so LDR R0 comma equal to 0xFF, which is nothing but the equivalent instruction is like this. You can see there is no change here, no major change, except that there is equal to here and there is hash here. Nothing but you're moving an immediate value FF to R0. So this is well within the range of the move instruction. Now you can see here this particular data which is not within the range of the move instruction. That is the reason we have gone for LDR R0 comma 0xFF 55555. So which clearly means that this is not a constant, but in fact it's it is a 32-bit address itself. So this 32-bit address, it can be replaced by an equivalent instruction which involves a program counter here. So the program counter there, let's assume that there is a some default address. That PC plus an offset value will actually give you this particular value. Okay, let's assume that this PC is equal to 0 right now. So 0 plus, and this offset is 55. So 0 plus 555 will give you this particular address. So when this instruction is assembled by the assembler, it is going to replace with the actual instruction like this. Okay, so the difference here is this number is out of range, so we did not translate this into a move. So that is the reason we cannot move a 32-bit constant, so which was actually mentioned here. And so there is no ARM instructions to move a 32-bit constant into a register. For that sake, we are writing, or we are taking the help of a pseudo instruction. Now same goes down to ADR also. Okay, same goes to ADR also. Okay, so nothing but we are loading an address here, and I told that it's a relative address. Okay, and first of all we need to know what is a program relative address. So here in this video I'm just going to write it down, since it's missing here. Okay, so ADR. So let's take ADR instruction. Okay, so we have mainly here it is relative address, a relative address which is moved, which is again classified into a program or a register, a relative address. Okay, again it depends on how it is used. Okay, it is again dependent on how it is used. So now we'll see what is program relative and a register relative. So let's take an example for that. Okay, ADR. Okay, and as the syntax goes, it is a register. Okay, a register. Let's take R2 comma, and let's give, let's say, is equal to 0 x. Let's take the 555 example, or let's take f 0 0 0 0. Let's take this as an example here. Okay, uh, either if it is a program relative, so it can be replaced with, uh, a PC value. Okay, like for example, if I take PC comma uh, hash 0x, again let's take f 0 0 0 0. Okay, so this is just an example here. I'm taking PC value to be 0, so 0 plus 0x fff will give you this particular address itself. So you can see that it's clearly a relative address. Relative to what? Relative to the program counter, and hence it is called as a program relative address referencing. Okay, so this is an example for a program relative address, and how it can be a register relative address. Now the same thing, if let's say if you have mentioned it the same way, again it depends on the assembler to consider it as a relative address or it will be like this. So I'll just show you here. It can be like R4 comma, so this we have included a register here. So now what happened, it has become a register, a relative address. Now let's take an example here. Okay, let's take an example here. I've brought in an example now here. So move R0 comma 10. Okay, there is a label here, start. Okay, and I've used ADR here, R4 comma start. Now that label actually is nothing but an address. Okay, which is referring to, which is having a reference to the program counter. This particular instruction actually is called as a pseudo instruction, and hence during assembly it is converted to like this, subtract. So either it can be an add instruction or it can be a subtract instruction. Since the label is placed before the ADR instruction, it's a, you know, a backward jump, not a forward jump. So hence we have a subtract instruction, and since the label is being referenced as a program counter, so it is nothing but coming under the category of program relative addressing. So we use the PC value. So PC comma 0, this is just, it's actually an offset address. Okay, so the offset address plus the PC value will give you the program relative address. Okay, so why the subtraction is used also I have given the example.